So this is my talk on pterosaur diets. So pterosaurs are an extinct group of Mesozoic flying reptiles found from the late Triassic to the latest Cretaceous and have been depicted filling a wide range of ecological roles, including carnivores, piscivores, and insectivores. However, the diets of many pterosaurs are quite contentious, and a search of the literature shows that 88% of all pterosaur dietary hypotheses are based on qualitative or even speculative reasoning. Now, pterosaurs are vital components of Mesozoic ecosystems, particularly those taxa who occupy the margins between terrestrial and marine environments. Thus, using robust quantitative measures to infer pterosaur diets is of vital importance to representatively reconstruct Mesozoic ecosystems. And the approach which I am using for my PhD involves 3D dental microwear textural analysis. So microwear, as the name suggests, refers to the microscopic wear patterns found on tooth surfaces which are formed through interactions with food items during feeding. And the material properties of food items can determine the type of wear patterns that form. So here are two topographic maps of tooth surfaces which in life are 140 by 110 microns in size of two modern bats, the horseshoe and the brown bat. So the pink areas denote troughs roughly 2 microns in depth, which are larger and more numerous in the horseshoe bat, and so this can be considered to be the rougher surface. Now, these textural differences do reflect the known dietary differences in these two bats, as the horseshoe bat prefers to eat beetles, which have thick cuticles and so are therefore harder for teeth to pierce, whereas the brown bat prefers butterflies and moths, which prefer to eat butterflies and moths, which have thin cuticles and are therefore softer. And these textual differences can be quantified using standardized roughness parameters and then visualized in multivariate space, as shown here with several modern bats, where the x-axis correlated or negatively correlated with the proportion of hard food items in the diets of these bats. Now, microwear is also known to be preserved in fossilized teeth. Thus, we can project the microwear of extinct taxa onto the multivariate space of suitable modern animals to infer the material properties of extinct diets. However, because pterosaurs have no modern descendants, I am using several taxon groups as modern proxies, including bats, monitor lizards, and crocodilians, which here comprise of 4 bats, 3 monitors, and 2 crocodilians. Now, the diets of these modern animals are known from stomach and fecal content studies. And one characteristic of diet, which is very easily comparable between these taxa, are the percentage of vertebrates in their diet, which range from the long-fingered bat, which is fully insectivorous, all the way up to the gharial, which is almost an exclusive fish eater. Now, for this study, we can argue that vertebrates are softer than invertebrates because the former do not have an exoskeleton which teeth need to penetrate through. And so I can hypothesize that microwear textual differences between these modern animals correlates with the percentage of vertebrates in their diet. So I sampled microwear from the labial, so outward-facing side, and from the non-occlusal, so non-chewing tooth surface of these animals. And when visualizing the textual differences in multivariate space, gives me something like this. So this is just the microwear of my bats. Adding the monitor lizards shows that they're more centrally based on the figure, and adding the crocodilians look a bit like this, with the gharial on the left and my juvenile saltwater crocodiles on the right. So PC1, the x-axis, was found to significantly negatively correlate with the percentage of vertebrates in the diets of my modern animals. So high vertebrate diets over on the left, low vertebrate diets on the right. PC1 also significantly positively correlated with the percentage of invertebrates in their diets, and quite interestingly as well, significantly positively correlated with the degree of dietary generalism. So as I mentioned just before, the gharial is an almost exclusive fish eater, so a specialist, whereas the long-fingered bat and the juvenile salties will pretty much eat any invertebrate they can fit into their mouths. And these results are of vital importance because they show for the very first time that microwear textual differences in non-occlusal tooth surfaces in unrelated modern organisms are determined by diet and not by phylogeny. And so what this means is this data set is robust and basically provides a robust comparison for me to now project my pterosaur microwear onto. So I currently have quite a bit of several teeth from 2 pterosaurs with different hypothesized diets. Rhamphorhynchus, which is a supposed piscivore, and Dimorphodon, which is a supposed insectivore. And so projecting their microwear onto multivariate space gives me something like this. So it gives me separation along PC1. So Rhamphorhynchus in R occupies the more high vertebrate to mixed feeder side of the figure, whereas Dimorphodon is more on the mixed feeder to invertebrate side. Now, the clustering together of individuals within a species and the partitioning of different species along PC1 means that microwear textual differences in pterosaurs are due to diet, and so I can reject the null hypothesis that pterosaur microwear is randomly distributed along this figure, and this now gives me the context with which to project pterosaur microwear from a greater range of taxa where I have fewer specimens. And projecting those taxa look like this. And so this gives me greater partitioning, so greater ecological partitioning along PC1. So some pterosaurs appear to have been more vertebrate-eating specialists. So Istiodactylus here in turquoise is far on the left, and this guy has been hypothesized as a scavenger. Now at this point it's unclear whether this was indeed indicative of a scavenger, an active predator, or a piscivore, but the fact that it plots strongly on the high vertebrate side of the figure is an encouraging find nonetheless. Also, we have basal monophenostratans here in blue. Now these guys have been thought of as fish eaters, and their overlap on PC1 with the gharial shows that this indeed might have been the case. We also have some pterosaurs which might have been more generalistic. So Pterodactylus here in orange is thought of to have been a generalist based on its relatively unspecialized dentition patterns, and its microwear shows this indeed might have been the case. Also, lastly, Darwinopterus here. So this one is quite contentious because it has been argued over the years to have been a carnivore, a piscivore, or an insectivore. And so looking at their microwear shows it plots more strongly on the insectivorous side of the figure. Thus, microanalysis is independently providing robust data which may resolve this particular argument. And so what does this mean overall? Well, this study shows that microwear textual differences from non-occlusal tooth surfaces in unrelated modern animals are determined by diet and not by phylogeny. Also, this study shows for the first time that pterosaur microwear textual differences are determined by diet, and perhaps most importantly of all, that microanalysis is revealing the characteristics behind pterosaur diet, such as the hardness of respective food items. And this is providing the first robust data towards representatively reconstructing pterosaur ecosystem, well, Mesozoic ecosystems, and where these guys fitted in their respective food webs. So thank you for listening.